All right, guys, we're going to remind you of something we did before, and this is actually wrapping up this section, in last section in chapter 8, okay? We're again talking about our similar polygons, okay? And what I have here are two similar polygons. In fact, okay, I have my green polygon, which is a smaller version of my blue polygon, okay? And I can change with this slider down here how much smaller, or if I want, I can actually make it exactly the same, in which case they overlap, okay? And in fact, when they overlap, we do see that they are similar because the angles A and A prime, B and B prime, C and C prime, D and D prime are exactly the same. So we have the similarity going here, okay? We have the similarity. The green polygon is similar to the blue polygon, okay? And if they are similar, then we want to take a look at the ratios, okay? So, and I can control this, and what we want to do is look at the ratio between the corresponding sides, the perimeter, and the area. So what I'm going to do is I'm going to try to make this polygon 1/4 the size of the original. Okay, so that means my green polygon, its sides are 1/4 the length of the sides of the blue polygon, or the blue polygon has sides which are 4 times greater. Now let's look at this, okay? So if I take the ratio of side AD to A prime D, it is 4. We're going to call it exactly 4. Now it says 4.01. We're going to call it 4. The ratio of their perimeters, the large polygon perimeter to the small polygon perimeter, is 4, which is the same as the ratio of the sides, okay? So the ratio of the sides we call the scale factor, and the scale factor is the same as the ratio of the perimeter. But now let's look at the area. Blue polygon has an area just over 35. Green polygon has an area just under 2.5. Look at the ratio, 16. 16 to 1. Ratio of the sides, 4 to 1. Ratio of the perimeter, 4 to 1. Ratio of the area, 4 to 1 squared. 16 to 1. 16 to 1. So the area, the ratio of the areas of similar polygons is going to be the square of the ratio of the perimeters, or the ratio of the sides. Now let's look at this again. Okay, so let me design this to be half the size, okay? So now I'm moving this, okay, such that, okay, my area, here we are, okay, my the sides of the green polygon are 1/2 the measure of the sides of the blue polygon, okay, or the blue polygon has sides which are twice every side of the green polygon. So the ratio of my sides is 2 to 1. 2 to 1. Okay, that is large to small, 2 to 1, small to large, 1 to 2. The ratio of my perimeters is 2 to 1. Okay, 2 to 1. All right. The ratio of my areas, however, is 2 to 1 squared. It's the square of the ratio of the sides, or the square of the ratio of the perimeter. Okay, so therefore, okay, it has a ratio of 4 to 1. Okay, let's exaggerate this a little bit. I'm going to make my polygon 1/10. Its sides are 1/10, okay, the original. 1/10, okay? So it's going to get very tiny, right about here, okay? Almost there, all right? But guess what, okay? You can't quite drive it there, okay? We're just going to accept that it's going to be 1/10, all right? Let's just get that as close as possible to 1/10, okay? There, close enough, close enough. Okay, so now what am I saying, okay? Every side of the blue polygon is 10 times larger than the green polygon. So the ratio of the sides is 10 to 1. The ratio of the perimeters is, okay, 10 to 1. The ratio of the areas is 100 to 1, okay? 100 to 1. In other words, okay, I could fit 100 of these tiny little polygons inside of this polygon. When the sides are in a 1 to 10 ratio, the areas are in a 1 to 100 ratio, okay? So the area ratio is, okay, the perimeter ratio squared. The area ratio is the ratio of the sides squared. The area ratio is the scale factor squared, okay? When we have a 1 to 10 ratio with the sides, meaning the polygon over here has sides 1/10 the length of its corresponding sides over here, its area will be 1/100th the area of this, implying 100 of these little polygons will fit in here, okay? So that's the lesson. The ratio of the perimeters of similar polygons is the square of the ratio of their sides. The ratio of the area of similar polygons is the square of the ratio of the sides, okay? So that's what you want to remember for the exercises we're going to have, and that is it, okay? That is it.